Hi everyone, I'm Nick Erner. I'm the Managing Director of Alkane Resources.
And I'm Ian Chalmers, Technical Director of Alkane.
So today what we're trying to do is to give you more information about the announcement we put out on Monday the 9th of November around our recent Boda drilling results. I said we were going to do this at the AGM, that Ian and I would do this together, because it really helps to give the context and explanation that we give to analysts and shareholders, or about to give to analysts and shareholders regarding these results. So the purpose of this is it's going to be a Q&A style format, and in doing so we answer the questions that I typically get asked, or Ian typically gets asked, about these results. So let's get into it. Firstly, a little bit about Alkane to recap from our AGM presentation. We're a company with a solid financial position. We've got an operating mine at Tomingley, which Ian and his team have given us significant resources to add to. We strongly encourage you to look at those announcements, returning into a high rate of production there. We've got Boda, which we're going to talk about. We've got investments in other companies. I won't go into too much detail on that. We'll get straight into talking about Boda. So Ian, why don't you start by telling us, what are porphyries and why are they in this bit of New South Wales?
Yeah, look, basically the Macquarie Arc is an Ordovician-aged island arc system that's been well known for many, many years, with some major discoveries over the last 30 years. We've Cadia, Ridgeway, North Parks and Cal, and these are all big parts of porphyry systems. There's major deposits in porphyry systems. So we've obviously been interested in the region for many years. We've focused on our Tomingley Peak Hill area for many years, got that Tomingley mine up and running after Peak Hill, and then started looking seriously around what's the prospectivity for porphyries in this region. To do that, we went back to basic science. We looked at the geology, understood what the porphyries were, how they were made, how they formed, and we involved with a very large academic study that came out of Codes in the University of Tasmania, the Geological Survey of New South Wales, and industry all participated. That set up the parameters, how these things formed, what drives them, how do you find them? And that's sort of how we started out. One of the key areas we looked at was what we call North Molong. So it's an area about 110 kilometres north of Orange, north of the Cadia operation. An area that had been explored by other major companies like Rio Tinto and Newmont and Newcrest, and then went back to basics and said, okay, how do we unravel this? What are we looking for? And that's how we developed the exploration project there.
Okay, so thanks Ian. So clearly Macquarie Arc, a whole host of really significant deposits in there. So how did we know exactly what we were looking for at Boda? What particularly were we looking for?
Okay, well we had the models at Cadia and North Parks to go from. So we sort of understood those and they're all well documented. So we looked at that model and said, how do we see that on the ground? We also knew from academic studies that these porphyry systems all throw out lots of other metals other than the gold and copper, the obvious ones. They throw out what we call pathfinder metals. And those metals can be done on a regional basis, can help you to zero in on targets. And that's really how we started off our work program.
So thanks Ian. So the slide we put up now is our particular tenement holding there, where we've got three main areas of interest. Can you tell us particularly about those?
Yeah, sure. Basically, what we know we have is all the right sort of rock sequences, the rock ages in what we call our North Molong project. There are three specific target areas. The primary one, the one we've started the work on most, is the Kaiser Boda at the southeast end of it. In the middle, we've got the Comabella area, and then up to the northwest, we've got the Finns Crossing area. So from other companies' exploration, like I explained before, like Rio Tinto, Newmont, Newcrest, we focused on the Boda Kaiser area first, and then just looked at the chemistry and geology of that, and then started to understand better how we could target those areas.
It's still highly prospective, and the others we're just really yet to get to those in significant detail.
Correct. Like in any exploration, you rate projects according to the data you've got. So you look at them and say, I've got a lot of data in Kaiser Boda, therefore I think it's a better target right now than Comabella and Finns Crossing. And that's why we started work in that area.
So Ian, looking at this particular slide we put up, the reason was to try and explain how Boda came to be in terms of a geological timeframe. Can you tell people about that?
Yeah, sure. Again, building on that sort of regional geological expertise we had, we also had other models, other ideas about the structural control, what makes these large porphyry systems. And we know in the region we've got north-south structures, what they call arc parallel structures, but also very importantly, there's cross-cutting northwest transfer or transverse structures they have right throughout the Macquarie Arc region in New South Wales. So looking at that, we were able to say, well, that those two structures, the northwest and the north-south ones, all coalesce around Boda Kaiser. And so that became a primary structural target as well as a geological target.
So Ian, we put up on this slide here, on the right-hand side, we've got the results that we put out on Monday the 9th. On the left, we've got the results we had even before we started the program. You know, I'm greatly encouraged, as we put in the announcement, by the results we got on Monday. Can you tell people why we're particularly excited about these results and the significance of what it means?
Sure. Basically, as I said about focusing, so we focused in on the Kaiser Boda area about several years ago. In 2017, decided to do some reconnaissance drilling, initially around the Kaiser area. Now, Kaiser's a small, high-grade gold copper ore body that outcrops on the surface, not big enough to be economic developed in its own right, but significant geologically. So we looked at that. We looked at how it fitted into the regional picture, did some drilling around Kaiser, then pushed the drilling out down to Boda. And at Boda, we started seeing the first indications that we might have been on the top of one of these big mineralised systems. In 2019, we went back with a program of drilling at Boda, and that was testing some of those shallow drill holes that we saw with encouraging mineralisation. And really the first round of drilling was very encouraging.
Beyond very encouraging. It was fantastic.
Fantastic, yeah, okay, that's a good way to describe it. Yeah. I mean, there were some really spectacular intersections, but most importantly, we're starting to see that important zonation that we know drives porphyry systems. So, yeah, there are large alteration zones. In Boda's case, they're 500, 600 metres wide. Within it, you get tighter zones, higher intensity alteration, where your gold and copper starts to get into economic concentrations. So we got that in the first round. Mm-hmm. We also then did some regional geophysical work, some induced polarisation, which we did over the top of the Boda area, the Kaiser area, to the north and to the south. That indicated chargeability features. So these are things in the ground which are showing some kind of electrical conductivity, which usually means sulphide content.
Strong guides.
Strong guides, absolutely strong guides. So the follow-up program that we just effectively started, and put out the first results, was really looking at Boda itself, trying to understand the geometry, and particularly the three-dimensional geometry, the high-grade zones. These are always difficult things to focus in on. What we've since learned, apart from that first program, is that those high-grade structures appear to line up in that northwest trend that we talked about earlier. Yeah. The northwest trend that effectively links Boda to Kaiser. So we're now pretty confident there is a northwest trend. If you look at our drilling and then look at our recent drill holes, basically, if you're looking at northwest trending structures, our drilling is largely parallel to those structures, which actually makes it quite difficult to understand the geometry of them, where do they go, how do they all fit together.
You're talking particularly some of the higher grade structures.
Not the big alteration zone, which is a large sort of blob and extending to the south. Basically, the high grade zones look like they have a northwest trend. That changes our view, and I'll come back to that in a moment of how we go forward. We also drilled to the south of what we've been calling Boda, into what we called Boda 2, and Boda 2 was identified by one of those chargeability anomalies. Shallow RC holes got mineralisation, certainly good indication of mineralisation. Hole 22 that we also reported really was an eye-opener. It was a very large pyritic alteration zone with very good gold grades, over nearly 300 metres. A very interesting target, a bit of a surprise where we got it, but indicates that this is a very large system.
Yes, certainly, looking at these results, it shows long mineralisation and a classic pyritic halo with gold grades, which is greatly encouraging about finding the core of these systems and on multiple high-grade intrusives.
Absolutely, and that's really where we are now. So the two things, just going back to the commentary about the northwest trend. So being concerned about that drill orientation, some of the holes we're now programming are going to be drilled from the northeast to the southwest, so that we cut across the structures. We try and understand the three-dimensional geometry, which means it makes us easier for them to find. Then to the south, we've got the shallow RC holes with mineralisation. We're now starting to go underneath those because we think what we saw in 22 with a big, broad, gold-rich halo, that there should be a high-grade core centrally in that section to the west. So that's where the current drilling is taking us. Yeah.
So Ian, sort of a moment of reflection a little bit to help explain to people some of the sections that we put in, which does talk a bit about the orientation that we just referred to. So on this slide here, we've got the section and a photo of some core. Could you explain that a little? And then as we're talking, we'll also go to I'll move it to the next slide as well, because in there we have even more sections. I'm particularly interested in people understanding the way a classic porphyry structure might exist, particularly similar to those at Cadia, and understanding contextually what we think we're looking at.
Okay, so the first slide is showing some of the original holes, and basically what it showed is, again, this big, broad mineralised system with some high-grade zones within it. Those high-grade zones are usually marked by plus 1 gram gold, certainly plus 0.5% copper. The slide, the right-hand side of that is showing the high-grade intercept we got in hole 7, which is a spectacular intersection, 94 metres at nearly 4 grams gold and 1.5% copper. It shows that it's a major breccia zone, and I'm talking about now these structures, the structures that control. The breccia zone, which we think now probably aligns on a northwest trending feature. So on the next slide, you'll see that the follow-up drilling around that, so we drilled a hole that went underneath that hole 7 discovery hole and really got back to the broad disseminated mineralisation.
To give people context, we're talking 200 metres underneath, right? Which is
a
very long way.
It's a fair way.
Yeah.
So while we're still waiting for more results to come in, and there's a hole over the top of that to try and understand the three-dimensional geometry, you'd have to say that what we got in hole 7 was actually plunging off the section away from hole 10.
Yeah.
So it actually moved away from hole 10 as we got deeper.
And another question, why is the core so black?
Okay, the core is black, and this is what makes it very different to, say, Cadia and to North Parkes. That we have, our sequence of rocks are largely andesites and basalts, so they're naturally blue-black rocks anyway.
Yep.
That intense potassic alteration we get is largely biotite. It's a potassic mica. So the rocks, which are largely blue-black rocks, getting altered to be black biotite rocks, it's very hard to see mineralisation, to determine the alteration boundaries. That's why we do a lot of lithochemistry, a lot of petrology on the rock to understand that sequence.
Yeah, and also for our investors watching, it's also why Ian and I don't say, hey, we've seen this in the core and therefore we expect this result, because there's a correlation, but definitely not a causality really between what we look at and necessarily the grades in this system.
Absolutely. I've been in the business a long time, and trying to predict grades from visual core is a very dangerous pastime.
Yes.
And in our case, particularly as we've talked about, we only talked about chalcopyrite, we also had bornite, which is a high-grade copper sulfide mineral. Bornite is naturally a dark bluey, purpley colour, which you can imagine that disseminated through a black rock, it's actually very hard to see.
So, Ian, I think just really quickly, if we could talk very briefly about the discovery of Ridgeway so that people understand a bit of the journey we're on. We don't have to go into it too much, but in terms of that sort of higher grade disseminated mineralisation and then how it comes about in terms of hitting it?
Yeah, Ridgeway is a very fascinating deposit. It's part of the Cadia system. So it was found after Cadia was developed and Cadia Hill was developed, and they were working on some geological models and some geophysical models, and they went in and did the same sort of things we would do. They drilled some shallow RC holes across the surface, didn't get very much, got some sniffs of mineralisation. They then drilled a couple of diamond core holes, and you can see that on that diagram on the left-hand side.
Yeah.
They drilled about 200 metres apart, those two holes, and the third one further off to the right again, and basically got very little. It was you'd classify it as being geologically interesting. When they went back and looked carefully at the geometry and the vectoring of the grades, they were able to say, look, maybe there's a target in the middle there. And then they drilled that discovery hole, which went straight into the top of the Ridgeway deposit. You look at that intersection, you'd have to say that's probably one of the most spectacular drill intersections in a porphyry system. That then made them look and say, well, why have the other holes missed? And they rotated their drilling around. You can see that on the right-hand side diagram, the drill holes all coming in from effectively from the east, defining what became the Ridgeway deposit, which is and it particularly the Ridgeway is interesting because it doesn't have a big halo around it. It doesn't have a big low-grade halo around it.
So to summarise this, we can say that you sort of do sneak up on these and then shift and change your knowledge to define them.
Absolutely.
And that's just what we're doing as well. It doesn't mean we're saying it's this, but it does mean we're following that methodology.
Absolutely. That's exactly what we're doing. You try and understand the three-dimensional geometry. You have to drill quite a few holes.
Yeah.
You think you eventually get it right and you test that model, and if the model's right, then great, fantastic, away you go. Yep.
So Ian, I put up this classic porphyry image which we've drawn. Can you tell me a little bit about the current drilling that we've just done, the one just put out on the 9th of November?
Yep.
Can you tell me, in this picture, where do you think we might be hitting, and what are we targeting with the next stage of drilling?
Okay, so this is our geologic model as it stands today.
Yep.
You know, there's still a lot we'll learn over the next year or two. Basically, what you can see on that is an outer propylitic zone, an inner propylitic zone. The inner propylitic zone is where you get the first appearance of significant amounts of pyrite. That's where, in our case, in hole 22, we're seeing the gold.
Yep.
When you go into the potassic zone in the middle, you start seeing increased chalcopyrite, pyrite and bornite.
And it's fair to say we're probably in that zone up at Boda itself.
We are, correct. So we're probably at the top of that image. So we've some of that sort of argillic alteration we see at Boda, but we're at the top of the image, and that means that there's still a lot of potential at depth to find a high-grade core. Now, sometimes those high-grade cores don't exist.
Yeah.
Sometimes they're a long strike from where you're drilling. So you have to understand the three-dimensional geometry.
Which is why we're drilling over such a long strike.
Correct.
So Ian, let's tie a bow around this and pull it together. The image we've shown is of the IP work that we've done. Can you tell me, what do we know and what are we doing next?
Yeah, interesting. So what we know we're in a big system. There's no doubt about that at all at this stage. We know that the system extends from at least from Kaiser, I'm pretty sure it goes to the northwest of Kaiser, down into Boda 2 and into the south again. So it's a 4 or 5 kilometre long system, which we've only at this stage scratched the surface.
We're sort of in that middle,
we're in the middle,
1.5 kilometre. Yep.
So we've learnt about the geology of that, we've learnt about the alteration, we think we're vectoring in on the high grade zones, but the current drill program will take some of that knowledge, we'll test out that northwest orientation for high grade, we'll test that out. We'll drill further to the south, so we'll fill in between Boda and Boda 2.
Yep.
We'll drill to the south of the Boda 2 IP anomaly, which is effectively a continuation of the same zone. We've got 1 or 2 holes scheduled to go into Kaiser currently, which we will need to look at because we think our understanding now of Boda changes the way we look at Kaiser.
And they're scheduled for sort of early next year?
Early next year, yeah. So the short-term focus is Boda 2, and then we'll look at what we're doing at Kaiser. So it's still a big program. We've completed about 8,000 metres, a 30,000 metre program. It's a very big program. A lot of our holes are 800 metres to a kilometre. They are deep holes in anybody's term. But that's where we think the system is. And basically it looks like it comes up to the surface or near surface in places. But probably in terms of grade-wise, maybe only 200, 300 metres down before you start seeing...
If we're hitting the...
Or we start talking about ore-grade material. So,
Okay, excellent. Thanks, mate. So if I can summarise to everybody, we have a very large system, that's completely clear.
Yeah.
We have higher grades within that system and we're zeroing in on the orientation we need to drill to better define those. We expect multiple intrusives of that type. We're now, particularly in this next phase of drilling, which we hope to release before Christmas, we have our first of the holes drilling from the northeast, but also we have the infill drilling along that sort of Boda to Boda 2 at depth. We've got 2 diamond rigs on site. We're drilling it hard. Obviously, we've got the rest of this 30,000 metre program to go, but then we're already starting to plan and look beyond that. Yeah. And so that really is it. It's early stages of what we think is a massive system. We're looking to define how it's economic, the size and scale of it, and we look forward to telling everyone much more about that as it comes forward.
Absolutely.
Fantastic. Thanks, mate. I appreciate your time in my office with our really high-grade poster in the background.
Yeah, thank you. Yeah,
You're welcome.
Yep.